Hello guys, welcome back to another session with the Marvel Tutors. So today we'll be tackling the functions problem. And I know that a lot of people out there, functions really got you scratching your head, isn't it? But you know that when you got Marvel Tutors, everything is under control. Again, if you want to enroll on our courses for just 100 Rand per topic, you can still text me and then we're gonna arrange for you just for 100 Rand per topic. You get everything, you get 100%. That is a guarantee. By the way, there's a lot of people who have actually enrolled on our course. Thank you so much for the support. All of them, as now as we speak, they are extremely comfortable with the topics that they've actually enrolled into. So if you want to join our program, you can just text me and then I will actually ensure that you get into the right topic that you want us to assist you at for just 100 Rand. It is 100 Rand for 100%. That is a guarantee. Well, if you're writing June exam again, or you're writing the final exam, this is actually for you guys to assist you. Now, let's actually tackle this functions problem. So we're being told that in the diagram below, A and B are the x-intercept of the graph of f at x. So we're having A and B, which are actually the x-intercept. That is just self-explanatory. Okay, now we're being told that we're having a straight line that actually cuts this whole thing at point A, at this point, and also at point C. And now when you read, you will find that MN is actually parallel to the y-axis. So I'll be teaching a little bit fast because, you know, I just want to cover as much as possible with little time. But if you want to have comfortable time with us, just enroll on our courses and get 100%. That is a guaranteed. I don't care who you think you are, you're getting 100. Well, now let's actually go into this question and let's try to answer this question. Now, the first question that pops up says, show that g at x equals to x plus 1, right? So we need to understand what is g at x. So g at x is actually this straight line, right? So we do know that the equation of a straight line is given by y equals to mx plus c. Right? It is given by y equals to mx plus c. And what do we have? We do have this point. And we actually know that this point is 0 and 1. So within this equation, we need to find the value of m. And the value of m is actually the gradient. So how do we actually find the gradient, ladies and gentlemen? We use this wonderful equation. So we're going to use this point and point C to plot within this formula of gradient. So y2 will be my 5, while y1 becomes my 1, and then x2 becomes my 4, minus 0. So this is going to be 4 divided by 4, and my gradient will indeed equals to 1. Now let me just, give you a little bit of another formula you can use, right? You can just like browse on with these formulas. Now let me introduce you to these rare formulas that people use. You can use this formula, y minus y1 equals to x minus x1, right? So let's just use any point between this point and this point to, actually exploit the information with this equation. So if you want to be smart, because I'm also teaching strategic thinking, you don't just go into the exam and write everything, right? You need to be having some sort of strategy of how you answer your things. So because you can choose any point between this point and this point to exploit within this equation, choose the point with less numbers, or choose the point that has extremely small numbers. And at this point, this one has extremely small numbers because it is just 0 and 1. But at this point, you're having 4 and 5. You don't want to waste your time. So you're going to say, okay, y minus the y1 is going to be this one, right? What is m? M is actually 1, and then x1 is actually 0, and then you're going to have y minus 1 equals to x, and then you're going to say y equals to x plus 1. Therefore, the g at x indeed equals to x plus 1. You see, so we have actually proven that g at x equals to x plus 1, and it is what they wanted us to prove. So use this one with smaller numbers. By the way, you can also use this one of c, but you imagine now having to subtract. Bro, strategic thinking. Marvel is tutoring here. Okay. Now let's actually go to this one. Calculate the coordinates of A and B. By the way, a lot of people make a mistake. We are calculating the coordinates of A and B coordinates. We are not calculating the x values of a and b. We are calculating the coordinates of x and b. Now, I want to show you what I'm actually emphasizing this. A and b actually falls within this quadratic expression. And we know that the equation of the quadratic expression is given by f at x squared minus 2x minus 3, right? So it is actually be given by f at x equals x squared minus 2x minus 3. You want to find the x coordinates. So you know that you're going to say let y equals to 0. So you're going to have 0 equals to x squared minus 2x minus 3. So I'm going to cheat this using the quadratic expression because it's a bit faster. This is what I do in today's exam. I know I'm teaching extremely fast, but the thing with social media platforms, you can actually make this video to go slower. I don't want this video to be long. I'm sorry, guys. To all of you who have been supporting me, continue the support, guys. We're gonna tackle this year. You're gonna make it, and your parents will be proud of you. With Marvel Tutors, everything is under control. Okay, let's actually now solve this. You find that x equals to 3 or x equals to -1. So a lot of people actually leave their answers at this point, right? You don't leave your answer at this point because you did not answer the question. The question have said you need to determine the coordinates of a and b. So which one do you think it's a? Obviously a will be the negative one because it is actually on the negative axis of the Cartesian plane, and then b is going to be the positive 3 because it is within the positive axis of the Cartesian plane. However, you don't end here. You just say, okay, a equals to -1 and 0, and then you say b is 3 and 0. By this, you have now answered your question. Don't just leave it here. The coordinates are these are not the coordinates, ladies and gentlemen. Okay, I think we're cooking, right? I think we're cooking at this point. Okay, they say determine the range of f at x, right? We want to determine the range of f at x. Now, a lot of people actually find difficulties within this kind of questions. And now a lot of people have actually asked me that, Marvel, how do we identify the range? How do I identify the range? Well, relax. I got you. When I'm actually tutoring you, you're going to get everything correctly. Relax. So what is the range? Let me just identify the range. So a range is the values of y within the Cartesian plane where f at x exists. Okay, let me just break this English down, right? A range means that when they say determine the range of f at x, they're actually trying to say, tell us from which points does f at x actually exist. Where does f at x exist within this Cartesian plane? But tell us those points using the y values. Let me repeat. When they said determine the range, they're actually saying that give us the points with which f at x exists, but tell us those points with the y value. So how do you actually do it? Let me just cover up everything, guys. Let me just cover up this thing, right? Let me just cover up this thing. Now, what do we actually notice? You are noticing this y, this y axis here. Is f at x existing at this point? We don't know what this point is. Is f at x existing? No, f at x is not existing, right? And then when you come to this point, now you start to actually see, this loop of f at x here, right? You start to see this loop of f at x. Now you start to notice that, wait, as we move the paper upwards, f at x starts to exist at this point. But downwards here, f at x, it is not existing, right? And then as you move the paper upwards, f at x is existing. F at x is existing. F at x is here. In other words, they're actually trying to ask you, when they ask you about the range, they're actually asking you, tell us, where is f at x? Now you start to see, well, f at x is existing at these points until upwards. You are having these two arrows. These two arrows actually tells you that this function will continue to spread upwards until infinity. But what did we notice? We have noticed that f at x starts to exist at this point, at the turning point, that's where f at x exists. Now, let me just show you something. Each and every single time they tell you to find the range, this is what you do. When they tell you to find the range, you're going to say, okay, I'm given f at x, right? That equals to x squared minus 2x minus 3, right? So you're going to use the equation of identify the x coordinates of the turning points. You know this formula, right? And then you're going to say negative, what is b? B is negative 2 divided by 2a is 1. All right, you find that your answer is actually going to be 1. So the x coordinates of the turning point actually equals to 1. Now you come back to the original equation. Whenever there is x, you will substitute 1, right? So you get that y equals to 1 squared minus 2 minus 3. Now I'm going to hit this with the calculator. 1 squared minus 2 1 minus 3, you find that this is actually negative 4. So what does this mean? It means that the coordinates of the turning points is 1 and negative 4. So what did I say? When you answer the question for the range, you need to tell them in terms of the y coordinates, where does this function f at x exist? You start to realize that, wait, ye, right? And then you say inclusive. Can you include this? Yes, you can include this, right? You say from negative 4, guys, this is negative 4 on the y-axis. This is negative 4. Can you see this negative 4? You said, wait, from negative 4 until we go upwards, until we go to infinity. Infinity is endless. So you say from negative 4 until we reach upwards to infinity, this function is existing. So you say from negative 4 until infinity. So for infinity, you use this bracket. If you want to learn these things on depth, you can just enroll into our course again. It is just 100 Rand per topic, and then you're gonna get 100%. I understand that I'm actually teaching you guys with a very, very, very fast tone because I don't want this video to exceed 20 minutes. It won't allow me to upload it. So if you want to understand everything on detail and start to get everything right, you can just enroll onto our course, just 100 Rand per topic, and then we teach you everything with math and science. We got you guys. Marvel Tutors got you. Now, let's actually come here. Oh, the other way you can just say y is greater than or equals to negative 4. From negative 4 until upwards, f at x exists, right? Let's actually move forward. Now, the question that we find, it now says, determine the equation of the tangent to f at x parallel to g at x. Okay, they say determine the equation of the tangent. Before we even go any further, what do we know about a tangent? We know that a tangent is a line that touches something at most one point. Let's say we have a circle, right? So we know that a tangent touches a circle at most one point. It doesn't intersect. It touches. When something moves like this, it has intersected the circle, and this is no longer a tangent. But a tangent touches at most one point. If you are having, a quadratic expression like this, right, the tangent only touches at exactly one point. All right, this is a tangent. Now, you need to identify at which part of this, function is this tangent actually located to. But how do you identify that? They say the equation of the tangent is parallel to g at x. Really? They say parallel to g at x. Which one is g at x? This is g at x, right? So you already know that if this tangent is parallel to g at x, you know that it is not going to be on this side, because when it comes to the upper side, it is no longer touching at one point. It is now intersecting at 2 points, right? So the only way the tangent is existing here, it means that it should be somewhere. Let me just try to draw using another color. It should be somewhere here, right? It should be somewhere here so that it can touch at most 1 point. So we do know that they're actually saying that these two things are parallel. Wait, what did we teach you on analytical geometry? By the way, if you want to go deep with these things on analytical geometry, because this is an analytical geometry concept, again, contact us for 100 Rand. Marvel Tutors got you. You just get your 100% and then you just get out of the exam room. Okay. From this equation, we know that the gradient actually equals to 1.